Okay, I'm going to work through the video in the week 3 module. I'm sorry, I'm going to work through the worksheet in the week 3 module. This is just going over some basic, using the basic derivative rules and applying them to some different functions. So you should have your derivative rule sheet out next to you while you're working on this. I have it sitting next to me on another screen, so I'm going to be kind of looking off to the side occasionally so I can tell you which rule I'm using. And I know the rules aren't numbered, but you can, in general, we can go from top and from left to right. So that first one that says the dA of dx is equal to 0, that would be the first rule, and then just second, third across the top, and then the next row would be the fourth, fifth, and sixth, etc. Okay? So for number 1, I'm trying to find the derivative of f of x. Notice there's some power rules applied here. So that's the fourth rule. There's also the second rule. There's also the first rule. And there's also the third rule, because we're adding things up, So I can take the third rule tells me I can take the derivative of each one of these things separately and then just add them together. So if I do that, let's blow this up a little bit. So I'm going to write this as f prime of x. And the power rule applies, both the power rule and the second rule apply to this first term, because the 3 goes along for the ride. And the power rule tells me to multiply out front by 4. So of course 4 times 3 would be 12. And the power of x drops 1, so that would be 3. And that would be times dx, which is just 1, so I don't write it. Now x cubed, that's just the power rule. That would be 3x squared times dx, which is just 1. This is the power rule and the second rule. So that would be 2 times 3 is 6, and the power drops to 1, so that would just be the first. And then finally, derivative of 2, that's the constant rule, which is the first one. Derivative of that is 0. So that would be my derivative. Notice this, I labeled it as derivative. I didn't just say that this is equal to that, because they're not. Right? This is the original function. This gives me y values. Right? This is the derivative, which this would give me slope values if you think about it, right? Because this is literally the change in y versus the change in x. So this is an equation that would help me find the slope. Okay? Number 2, we have to hop down to the second row for this. So this would be the, what would that be? 1, 2, 3, 4, fifth rule. So the derivative of this is, this one says I got to multiply by the natural log of the base, which would be natural log of 5, and then I just rewrite the original function. Right? Number 3 is similar to number 1. I'm going to apply the second rule and the power rule and the third rule. So that would be what, 15x squared plus 2 times 4 is 8x to the first. Number 4, I got to hop down to the third row now. The third row tells me that the derivative of sine is cosine. So this would just be cosine x times dx, which is just 1. And the derivative of cosine, according to the 6th, 7th, 8th rule, that would be equal to negative, so I'll change that plus to minus, that would be negative sine x times dx, which is just 1. Okay? Now, number 5, this is where it gets a little bit tricky. F of x equal to cube root of x to the 5th. So now this is where you've got to be careful with your labeling, because the first thing I would do here is use some algebra to rewrite this. So now I'm not taking the derivative right now, so I'm saying that this is equal to what I'm about to write. Because I could rewrite this as x to the 5/3 power. Because remember, the power, if I'm writing a fractional exponent, the number on top is the power and the number on the bottom is the root. So this is the exact same thing as that. I haven't taken the derivative, it's just another way of writing it. And the reason why I'm doing this is because this makes it a lot easier to see how to handle it with the derivative, because this is clearly just a power rule then. So now I'm going to go ahead and write f prime of x, because I'm making whoever reads this understand that now I'm actually going to take the derivative. I haven't taken the derivative yet. This is just the original equation still. So then when I take the derivative, I get 5/3 times x. Drop the power 1. So 5/3 minus 1 would be 2/3, right? Because 5/3 minus 3/3, that's same thing as 1, would be 2/3. Okay? And then we'd multiply that by the derivative of x, which the derivative of x is 1. Dx dx is 1. Okay? So now the next one, again, this looks like, if you're looking at the rules sheet, if you go way down to the bottom, there's this thing called the quotient rule, when you have something divided by something. But since we haven't learned the quotient rule yet, you must be able to do this another way, and that's exactly true. So what I'm going to do first is use my knowledge of algebra. I know that when I'm dividing something, when I have a fraction like this, it just means division. So you could use the distributive property to divide x squared into each one of these separately, right? That's the distributive property says I can do that. So what I'm going to do, again, I write a little equal sign here because I'm not taking the derivative. I'm using some algebra to rewrite this. So 5x cubed divided by x squared would just be 5x. 4x squared divided by 4x squared divided by x squared would just be 4. Negative 2x divided by x squared would be negative 2x to the negative 1. And 4 divided by x squared would be 4x to the negative 2. Isn't that fun? So now this is what we're saying is this is the exact same thing as that. There's no difference. It's algebraically equivalent. So now I'm going to go ahead and take the derivative because it's in a form that's easier to deal with. So the derivative of 5x, that would just be 5. Derivative of 4, that's just a constant, so that'd be 0. The derivative of negative 2x to the negative 1 power, that's the power rule. So negative 1 times negative 2 would be positive 2. And when I drop the power 1, now be careful here. Remember, if I drop the power 1, that means I'm taking negative 1 and subtracting 1 from it. So that would actually take down to negative 2. And then finally, this last one is the power rule again. So negative 2 times 4 would be negative 8. And drop the power 1, and that would be negative 3. And of course, all these are times dx dx, which is just 1. Okay? So number 7, this is a combination. I'm using that third rule again where I got something plus something, so I can just take the derivative separately. So I'm going to go ahead and take the derivative right now. So the derivative of ln x, that would be the 6th rule, right? Remember, ln x is just log base e. So if we write that as log base e of x, the 6th rule tells me that I got to put 1 over x. Then I need to multiply it by the natural log of the base. So that would be natural log of e. Now, anyone that's passed 141, Math 141, knows that natural log of e is just 1, right? Because the natural log and e undo each other. So actually, this would just be 1 over x. Okay? Plus. And so then the next one, e to the x, when I take the derivative of that, I go to the 5th rule, and that says that I need a natural log of e out front, because e is the base, times e to the x. But once again, natural log of e is just 1, so this would actually just be e to the x. Okay? So here's some trig functions. We just got to find the trig function derivative on the rule sheet. That's tangent is in the 3rd row, so it looks like that's a 9th rule. And it says the derivative of tangent is secant squared. So this would be secant squared of x dx dx, which is just 1. And then if we find secant on there, the derivative of secant is down in that 4th row, which would be the 10th rule. Looks like the derivative of secant is secant tangent. So this would be secant x tangent x dx dx, but of course dx dx is just 1, so I don't bother writing it. Okay? Cruising along here. Here's some nice fractional exponents. No problem, it's just a power rule. I can handle that. That'd be 2/3 x. 2/3 minus 1 would take me down to the negative 1/3, right? And here we go, 1/3 times negative 4, that'd be negative 4/3. And again, if I subtract 1 from 1/3, that'd be negative 2/3. Of course, both these have a dx dx on them, which is just 1. So we don't bother writing it. Here's a log base 5. We're getting to be, we've done about 4 of these now on videos, so hopefully we're getting better at them. So when I take the log of something, it's going to be 1 over the thing I'm taking the log of times the natural log of the base of the logarithm. In this case, natural log of 5 is not just 1 like in the previous one, so I have to leave it there. And then, of course, this would be times dx dx, which is just 1, so I'll bother writing it. Okay, I don't think I'm going to do all of these, but hopefully you're getting the idea. Here's another one. Oh, let's drop down to this one. This is a cute one. So first thing I would do is remind myself that this is, well, I'll just rewrite all of this. And this is really x to the 1/3, right? So then I would take one more step here and rewrite this as, so I'm going to divide, use the distributive property again. So x to the 1/3 divided by x 1/3 is just 1. X to the 2/3 divided by x to the 1/3 is x to the 1/3. And x divided by 1/3 would be x to the 2/3. If you're not sure how I'm doing that, remember when you divide two powers that have the same base, you can just subtract their exponents, right? That's kind of the quick rule there. So that's what I was doing. And so now, notice all these are the same. I haven't done anything yet. Now I'm ready to take the derivative. So when I take the derivative of 1, that's 0. The derivative of x to the 1/3, that would be 1/3 times x to the negative 2/3 plus 2/3 times x to the negative 1/3. Okay, should we do one more here? Yeah, let's do this one. Yeah, that's just a mixed bag. You should have did that one. So let's do this one. Once again, we know that's x to the 1/2, so this would be 4x to the 4/2. That would be 3/2 plus 3x to the 1/2. That's not the derivative, that's just another way of writing the original equation function. Now I'm going to take the derivative. 3/2 times 4 would be 6 x to the 1/2. And 1/2 times 3 would be 3/2 times x to the negative 1/2. Okay, so hopefully that'll help you ferret out those rules a little bit. Just continue practicing if you want to get better and better at these, and even quicker. At first, you'll probably have to check the rule sheet a lot, but hopefully you'll begin kind of weaning yourself from the rule sheet, because you want to be able to do these off the top of your head and not have to go back and look at the rule sheet again and again and again. So keep practicing. These things take a lot of practice.